so much for joining us today for the Taking Flight from Chemical Pesticides webinar. I'm Joyce Kennedy with People and Pollinators Action Network, and we're excited to have our webinar partners, Hardy Kern from the American Bird Conservancy presenting today, and Chris Talbot-Hendel from Rocky Mountain Wild to say a few words about Colorado Endangered Species Week. As you may know, PPAN's work stretches from advocating for the protection of native pollinators to education and actions that promote sustainable and land management practices, reduce pesticide use, safeguard public health, and preserve biodiversity. And we've been so pleased with the strong interest in these topics and more through our free monthly webinar series. So thanks so much for being here. As you also may know, PPAN advocated for a pollinator and human health bill earlier in the legislative session, and unfortunately that died in committee. However, I'm happy to announce that the pollinating insect study that PPAN also advocated for did pass in the Colorado legislature in the final hours of the 2022 session. And this study will mean that the Department of Natural Resources will work on documenting the current health of Colorado's pollinators based on existing research and information, look to identify gaps in knowledge and protection so that overall the state can begin to lay a more comprehensive framework for statewide approach to pollinator protection. And just a few housekeeping issues. Please keep your microphone muted during the presentation and use the chat box for questions and address your questions for all to see. We'll do our best to answer them at the end. And we will be recording this presentation and we will post it to our YouTube channel soon, and we will send that information out once we do that. I'd like to invite Chris now to say a few words about Colorado Endangered Species Week.
Thank you, Joyce. My name is Chris, and I work with a small nonprofit called Rocky Mountain Wild. And every year we put on Colorado Endangered Species Week, which is really just a week to learn and do some advocacy to help some of the more imperiled, at-risk, threatened, or endangered species here in Colorado. So I will drop in the chat the link to the page. We're going through Saturday, but if you missed any of the days, you can always go back and check it out. We cover one thing every day, pollinators being today. So feel free to check that out. And I just really want to thank Joyce for organizing this and inviting us to use it for Colorado Endangered Species Week to introduce our audience to the threat of pesticides. So thank you so much. And if you have any questions about Colorado Endangered Species Week or Rocky Mountain Wild in general, feel free to reach out. I'll drop my email in the chat as well. Thanks.
Thank you, Chris. Well, we have Hardy Kern here today, who is the Director of Government Relations for the American Bird Conservancy's Pesticides and Bird Campaign. His portfolio includes a wide range of toxics issues, including agricultural pesticides, rodenticides, and lead. Hardy received his BS in zoology from the Ohio State University and worked as a zookeeper for 10 years before receiving a Master of Public Administration degree from Kent State University. He began working at ABC in January of this year. So welcome to Hardy Kern. Please take it from here.
Awesome. Thank you so much, Joyce. Thank you everyone for joining us today. I am so excited to be part of this month that you are putting on. And Chris, thank you so much for everything that Rocky Mountain Wild is doing as well. So today's presentation is cleverly, because we're a bird group, take flight from chemical pesticides. And like Joyce said, I am with the American Bird Conservancy. And if you haven't heard of the American Bird Conservancy, ABC is much easier to remember. We work to conserve birds across the Americas, and pretty much anything that has to do with birds or bird conservation, we are involved with in some way or another. We have scientists across the country, almost in all 50 states, actually, that are actively engaged in field work. We also have field staff in Canada and in Latin America. We engage a lot in policy and advocacy, which is kind of one of my roles at ABC. We have a lot of different work that deals with a lot of different threats to birds, everything from climate change to different challenges posed by renewable energy to bird conservation, to invasive species, and even things like house cats, feral cats, things like that. We engage in a lot of outreach and awareness about bird conservation. And one of my favorite things that we do is we operate an international reserve network. So we manage tracts of land in both birds' summer and winter residency areas, and we're able to kind of provide safe spaces for birds everywhere that they're found. And it's only because of the great partnerships that we have with groups like PPAN and lots of other NGOs and government agencies that we're able to do this work. So thank you all for tuning in today. And diving right into it, we'll start with a little bit of background. What is a pesticide? This is a word that we're all very, very familiar with, but the actual definition of it might be a little bit surprising to some people. So the National Pesticide Information Center, which is a publicly accessible website that is run by the EPA and I believe it's the University of Oregon, defines a pesticide as any substance intended for preventing, destroying, repelling, or mitigating any pest. And that gives an enormously wide breadth as to what qualifies as a pesticide. Basically, any chemical, material, or strategy whose goal is pest reduction or pest repellency can be deemed a pesticide. So this includes herbicides, things that are targeting plants, fungicides, which are chemicals or strategies that are going after funguses, mushrooms, things like that, that we might not be wanting around our homes and gardens and in our agriculture. Insecticides, so chemicals that are geared towards killing or repelling insects. Disinfectants, believe it or not, some disinfectants can be termed a pesticide. Rodenticides, so chemicals or strategies that are targeting mice and rats and other pest rodents. Repellents, and this one was the really surprising one for me when I started doing this work, but technically some types of bug spray that you might just put on when you go camping or hiking can be deemed a pesticide depending on how they're regulated or how they're registered. And this is a very, very broad look at everything. There's lots of other categories that we could get into, but for the purposes of today and bird conservation, this is kind of where we're going to stay. And when we talk about pesticides, they can be synthetic, like the chemicals that you can buy at the grocery store or your home and garden store. They can be biological. Believe it or not, there are people that are using natural chemicals or even strains of bacteria as an insecticide or herbicide. And then they can also be organic. So there's a huge market right now for essential oils as a pesticide as well. Pesticides are pretty much ubiquitous in our society anymore. We use them in our lawns, in our homes and gardens. We use them in a lot of different parts of recreation, such as turf fields or golf courses to keep our grass looking pristine. And then the biggest use in the United States is, unsurprisingly, in agriculture. So we use a lot of different pesticides to help with our food production because we want to make sure that the apples that get to your local grocery store look really nice, and myself included. I don't want to bite into an apple and find a bunch of worms and other bugs hanging out in there. That's going to ruin your whole week probably. But the overuse of pesticides in American agriculture certainly does pose a problem for wildlife conservation and especially bird conservation. And when we're talking about the use of pesticides, it's really all about weighing costs and benefits. What we're looking to do is balance pest removal or pest repellency against human safety and environmental safety. So What pests are we facing? Will they become resistant to different chemicals and strategies that we're using? What will yield affordable crops, beautiful grass? So those are all the things that we're looking for, versus, is it going to have adverse effects on human health? Is it going to negatively impact the environment? Will it last in the environment for a long time? And if the answer is yes, then we need to weigh that against the benefits that we're getting from it. So there's a lot of back and forth when it comes to pesticide regulation. And speaking of pesticide regulation, anytime that you get into any kind of government work or scientific regulation, there are just acronyms left and right. And this is one of my favorites, FIFRA, the Federal Insecticide, Fungicide, and Rodenticide Act, FIFRA. This is the main piece of legislation in the United States that deals with pesticide regulation and pesticide registration. It was first passed in 1947. And not only does it look at when companies are looking to register a brand new pesticide or a new use of an existing pesticide, but it also governs the labeling requirements. If you go to your local garden store, or if you are a farmer and you're looking to use a pesticide on an entire field of crops, when you look at the container that that pesticide has come in, there's a label that lists exactly how you're supposed to use it, what sort of personal protective equipment needs to be employed while you're using that pesticide, and even sometimes what species it can adversely affect. And so FIFRA governs all of those labeling requirements. And when it was first passed in 1947, it was under the purview of the United States Department of Agriculture to oversee and enforce. And then later on in 1970, when the Environmental Protection Agency, the EPA, was formed, because pesticides go far outside the realm of just being used in farming, it was decided that because the EPA is a good bit broader and employs a lot more science in its review processes, they should be the ones to administrate FIFRA. So I know this is a lot of jargon and a lot of technical back and forth, and I promise you there's not a quiz at the end of this. I'd be happy to provide resources as well and answer more questions later on to clarify some of this. Basically, what it boils down to is when the Environmental Protection Agency is looking to register a new pesticide by a company, or if they're reviewing the registration of an existing pesticide, there's a few different questions that they need to ask. Number one, how does it work? So what is the method of action of this specific pesticide? Does it work on neurological signals? Does it inhibit insect growth? Does it block respiration in a fungus? So what's the actual mode of action? How will it be used? Is this to be sprayed out of an airplane? Is this going to be pumped out by hand by an agricultural worker? Is this something that we're putting in those little plastic push carty things in our front lawns? How is it that it's going to be used? Does it pose risks to humans? Is it dangerous to wildlife? And ultimately, and perhaps most importantly, where will it wind up? A lot of us like to think that when you go out and you spray something on leaves in your garden, it's just going to stay right there. But a lot of times that chemical can pretty easily travel into other parts of the environment. So all of these questions are what EPA is supposed to be considering when they're looking at registering a pesticide. And we'll talk about the challenges with that in just a moment as well. So getting on to what we want to focus on today, the kind of the intersection of pesticides and birds. One of the main ways that birds are affected by pesticides is through direct exposure, and that might be ingesting a pesticide, so eating a seed that's coated in a pesticide, or a berry, or small granules that you might use on your lawn. Dermal or inhalation, which means when pesticides get inhaled by a bird, or if they happen to get on their skin or on their feathers. And then also interaction with pesticides, which might come up through a plant. So a systemic insecticide or a systemic herbicide is one that is grown into a plant as it's developing. So even though you might not have sprayed a flower with an insecticide that could be harmful to birds, if the seed that flower was grown from was coated in a pesticide, every single part of that plant is going to have some of that chemical in it. So that's a way that a bird might become exposed to it inadvertently. And believe it or not, it's thought that up to 67 million birds are lost to pesticides alone every single year. And this is based on data from 2005. And in the United States, pesticide usage has only increased since then. So unfortunately, this number is likely even a little bit higher now. And when we're talking about the different ways that birds are exposed to pesticides, we're going to look at it both in agricultural settings and then in private use settings. Agriculturally, the main ways that pesticides are used are as seed treatments, where the outside of a seed is actually coated in a pesticide. As a spray, so that might be a person walking through a field and spraying pesticide, or coming out of an airplane or out of machinery. And then soil drenching, which is exactly what it sounds like, where the ground is quite literally flooded with pesticides in a way to treat the roots of the plant. And then in private uses, different ways that birds might be exposed are when we use them in our gardens, usually as sprays or sprinklings on the ground, on our lawns. So those the chemical treatments or the granules that you might spray to get rid of crabgrass, or if you hire a company to come out and treat your lawn. And then also on golf courses and other recreational facilities where there's a lot of grass, because we need our grass to look pristine, and sometimes we don't exactly care how it gets to that point. And when we're talking about especially agricultural pesticides, there's one group of pesticides that is more used than any other one, especially in agriculture. It is very widely used across the US, and that is the group of insecticides, so insect killing pesticides, called neonicotinoids, or neonics for short. If you want to impress your friends at parties, neonicotinoids is a very long, kind of fancy sounding word. And all that it means is a group of insecticides that targets the nicotine receptor in an insect's nervous system. So the way that a neonicotinoid actually works is it inhibits chemical signal transduction inside a bug's body. What does that mean? When an insect interacts with a neonicotinoid, it keeps the muscles from contracting correctly. It keeps signals from getting to the places where they need inside their body. And that usually means that insects will convulse. They won't be able to move around a lot. And eventually they will die, sometimes from a nervous system overload. And this is exactly the same thing that happens in other groups of animals when they're exposed to neonicotinoids. Neonics can affect birds, non-target insects. So if you're spraying for aphids in a farm field, most of the other bugs in that field, like mantises, grasshoppers, and crickets that might be beneficial to have around, are also going to be affected by those chemicals. Large mammals like white-tailed deer, opossums, and raccoons all show negative side effects when they are exposed to neonicotinoids. And even humans, there's not a ton of studies out there, but there's some really interesting work coming out of Asia that actually looks at some different pregnancy level interactions between neonics and humans, and some birth and developmental disorders, unfortunately, that can result from them. Neonicotinoids persist or last for a very long time in soil. In some cases, it's as short as 18 days. In a few cases, it has been as long as 2 years that neonics have remained active, and they're highly water soluble. And what that means is when they are sprayed on a field, or if they are grown into a plant from a seed, anytime that they get wet, most of that chemical is going to be carried away. They are very actively transported by water, which means it's really easy for them to leave the field or the lawn or the garden where they were supposed to be contained and get to other places where we didn't want them to wind up. So on this graphic here, we've got this sad little honeybee that was exposed to neonicotinoid, unfortunately. And as you can see, as it says down here, pesticide then attacks the central nervous system of the honeybee, leading to muscle paralysis and death. The honeybee was not at all the target of this, it was not the target pest rather for this neonic, but because it's systemic, because it grows from the seed up into every single part of the plant, even bugs that you didn't mean to target wind up becoming the victims of neonics. And that is some of the work that PPAN does, is focusing on the negative interactions towards bees, and then all of the environmental cascades that we have from that. So just to give you a little bit of a scope of how frequently and how much neonics are used in the US, on the left here, we have a graph. This only goes from 1994 up until 2014. And the top part here are the millions of kilograms of neonics that were used in the United States for those years. So as you can see, when neonics were first registered in 1994, they weren't very widely used. And then in 2004, we started noticing how effective they could be. And then their use has just grown exponentially since then. And it's actually gotten even higher since 2014. And one of the reasons why neonics were introduced was because we were starting to see really negative effects from other agricultural chemicals, such as malathion, diazinon, and chlorpyrifos, or organophosphates. So some really nasty, really effective chemicals. And neonics came on the market, and they were supposed to be this wonder chemical. They were so much stronger and so much more toxic than other chemicals that once we started using neonics, there was a bunch of other chemicals that we wouldn't have to use anymore. Less chemicals overall meant a healthier environment. You know, this was just the greatest thing that's ever happened in the petrochemical industry. As you can see from this bottom graph, though, this looks at all other pesticides that are not neonics used in the same frame of time, and their usage pretty much stays the same. So even after neonics were introduced, there wasn't this big reduction in the usage of other chemicals that was promised. Instead, neonics were used a ton, as were a lot of other chemicals. And then on the right, this big map, this is from 2014. This is data taken from the US Geological Survey, which is a federal agency, at the rough usage of the neonicotinoid imidacloprid in the United States in 2014. As you can see, it mostly overlaps in areas that grow a lot of corn and a lot of soybeans. That is most of the use of neonics because they are often used as a seed treatment. And corn and soybeans are the US's #1 agricultural products. So this quote, beginning in 2015, the provider of the surveyed pesticide data used to derive the county level use estimates discontinued making estimates for seed treatment application of pesticides because of complexity and uncertainty. What the heck does that mean? Basically, what USGS was saying is that up until 2014, neonics, including those used as seed treatments, including those used to coat seeds, as you can see here on the right, were counted in terms of how much pesticide was being used in the US. However, because they were used so ubiquitously, and because unfortunately they are not, when a neonic is used as a seed treatment, it is not registered as a pesticide, they became very hard to track. So rather than doubling down and really trying to figure out how much pesticide was being used, USGS just kind of said, okay, we're going to stop even counting the amount of neonics used as seed treatments. And here's why that's important. So this is a map for the use of clothianidin, which is another neonic, in 2014. And remember, in 2014, we're counting neonics that are used as seed treatments, as well as neonics used in other ways. So soil drenching, spraying it on the leaves or the fruit or what have you. And then in 2015, we stopped counting seed treatments, and look at how much this map clears up. Again, this is not saying that there are actually fewer neonics being used. We just stopped counting the uses as seed treatments. And look at the massive change that we see in the United States. This graph down here at the bottom as well shows, it's very similar to the one that we saw earlier, the overall increase in neonic usage. And then all of a sudden, it drops off here in 2015 because we stopped counting how many neonics were being used as seed treatments. Again, these are not neonics that have been taken out of the environment. We're just simply not counting them anymore. And when neonics are used as a seed treatment, unfortunately, most of that poison that's on the outside doesn't make it into the plant, which is the entire target of it. It is actually lost into water. It's lost into the soil. It's even lost as dust, which farm workers can then inhale. And when it gets into water, it can kill aquatic invertebrates that are not at all its target. When it gets into the soil, it can kill a lot of the different bugs and the other beneficial invertebrates that live there. And it was found in 2013 in a report that ABC did that just one seed, one single seed coated with neonics is enough to kill a songbird. A bird eats a single seed coated with neonics, and that is enough to be lethal. And unfortunately, due to a very strange clause in FIFRA, the Federal Insecticide, Fungicide, and Rodenticide Act, a seed that is coated with a neonic is neither registered nor regulated as a pesticide. Many farmers, even those that don't want these treated seeds, have no option but to use them, because about 10 years ago, the same companies that are the largest chemical manufacturers in the US that are making a lot of these pesticides bought the seed producers. And so the seeds are sold to farmers already with these chemicals on the outside of them. And here's the real kicker. It sounds really great that you might have a pesticide grown into a plant, oh, that's awesome, because then you don't have to spray them on the outside. Isn't this going to kill a lot more bugs with a lot less chemical? The truth of the matter is, after several studies have been conducted, there's only about a 3 to 5% yield increase in soybeans. So that's it. That's the entire benefit that we're seeing. The same effect has been found in corn, in wheat, in a lot of different leafy vegetables, such as lettuces and cabbage and things like that. So of all the chemical that's put on this seed, 90%, over 90% is lost off of that seed. Only 2 to 3% is even taken up into the plants. And in the fields where this is being used, there's only a 3 to 5% increase in productivity. So we have all this loss, all this negativity going towards using these seed treatments. Another chemical that's definitely worth mentioning is chlorpyrifos or chlorpyrifos, depending on who you talk to. And that is an organophosphate. It has been found to permanently damage a sparrow's ability to navigate and has also caused an inability in sparrows to move. And that was in a study conducted back in 2017. Chlorpyrifos has been on the market since the 1960s, and we've known about its negative impacts on wildlife and people since the early 1970s. And it wasn't until last year that the EPA started to take really big steps towards removing it from wide use. The other thing that is really good to remember is that when a chemical manufacturer is performing these laboratory tests for the EPA, and they're saying, okay, here's how this chemical affects bugs, here's how it's going to affect bees, here's how it's going to affect birds. And they do have to run laboratory tests. A lot of times these laboratory tests are not necessarily transferable to the real world. For instance, if you are a sparrow that has ingested chlorpyrifos and all of a sudden you are no longer able to fly, even for a matter of hours up to a day or two, if you're in a laboratory, no big deal. If you're out in the real world and you can't fly, that means that you can't evade predators. That means that you can't get enough food to feed yourself. That means you can't even get in out of the rain. So definitely something to keep in mind as we're reading about all these chemical manufacturers and the rigorous studies that they have performed. Chlorpyrifos was finally taken out of wide use by the EPA late last year and early this year. But the way that they did it was a little bit funny. So rather than saying chlorpyrifos cannot be used at all, they said chlorpyrifos can no longer be used on food that is going to be distributed within the United States, which means if you were a farmer growing food that's going to be exported out of the country, you can still use chlorpyrifos. If you are growing nursery plants, you can still use chlorpyrifos. And if you want to use chlorpyrifos on your farm or your golf course, that is still totally fine as well. So this was a really big loophole that has left space for chlorpyrifos to continue to negatively harm large swaths of bird populations. And especially for certain populations like salt marsh seaside sparrows and the black rail, which is an endangered bird in a lot of different parts of the country, a single negative event could wipe out an entire species or an entire population. The other way that birds are often impacted by pesticides is when the ecosystem itself is impacted. So perhaps the bird, in these cases, isn't necessarily directly ingesting a chemical. There's still ways that it can be affected. Number one is when they lose their food sources. So With the seed treatments, we talked about the chemicals running off into ponds and into groundwater, which means that the bugs that the birds are relying on to eat are disappearing, or the other invertebrates such as shrimp and other small aquatic invertebrates. Pardon me, gotta sip my tea here for a second. Something going around like all across the country. The second way that it might impact birds negatively is by contaminating their habitats. A lot of water sources, a lot of different fields and forests where there might be accidental chemical runoff. And then also in national wildlife refuges where a decent amount of agriculture is performed, the more that we use chemicals, the more that plants and pests will develop a resistance to them. And so we are also seeing national wildlife refuges becoming less productive as more and more pesticides are being used, which means that they're not as great a habitat for the birds that rely on them. In the Netherlands, back in 2014, there was a really interesting, very groundbreaking study by a scientist named Dr. Hallman. And what he looked at is where the neonicotinoid imidacloprid was used in different parts of the Netherlands. And what he saw was basically if you overlapped a map of the places where imidacloprid was used, and then you put on top of that the map of different declining bird populations, they were virtually one and the same. So if you look at this graph down here, on the left, we have mean species trend, which is basically population growth of different bird species. And then along the bottom is imidacloprid concentration. So as you can see, the higher imidacloprid concentration got, the lower the species trend became, which means that the more chemicals there were, the fewer birds that there were. And the other thing that he looked at just to make sure he wasn't missing something was all the other variables that could possibly contribute to there being fewer birds. And of everything that he considered, the thing that had the strongest correlation and really the only statistically significant one was imidacloprid concentration. You can see up here, this is the overall effect and the overall use of imidacloprid. And then over here in column B, the standard effect size on bird populations, this huge negative trend directly correlated with imidacloprid. And what he concluded was that it wasn't necessarily that the birds were ingesting this chemical, it's that the bugs that the birds relied on were being wiped out when imidacloprid was making its way into their ecosystems. And we're not going to go all the way through this chart here, but as you can see, basically what it's illustrating is that once a pesticide runs off and gets into the environment, it can be very, very difficult to get it out because once it gets into the water cycle, especially for highly water soluble chemicals such as neonics, it just keeps going and going. And then there's also the issue of agriculture on national wildlife refuges. And many national wildlife refuges across the country, there's over, I believe in the contiguous 48, there's over 95 million acres of national wildlife refuge. Cooperative agriculture is employed, which means that farmers are contracted in to grow wheat and corn and soybeans and all sorts of other things that are meant for migrating birds to stop and eat to make sure that they have enough calories as they're going about their migratory year. Unfortunately, pesticide usage is allowed on national wildlife refuges. So these areas of land that were specifically set aside for species conservation are being poisoned by toxic pesticides. And that is something that we're actually working very hard right now to reverse. And by the way, there's no data publicly available since 2014 about how much pesticide is being used on national wildlife refuges. And then there's also the Endangered Species Act, which was enacted in 1973. As part of the Endangered Species Act, there's a very specific clause that says anytime that a newly registered pesticide may inhibit a federally listed species. So if a new pesticide is going to possibly have negative impacts on an endangered species or threatened species or critical habitat, the U.S. Fish and Wildlife Service and the National Marine Fisheries Service are both compelled to do an in-depth investigation to really look at what measures can be taken to mitigate this, how can we help? The EPA, of the 4,100 chemicals that it has since gone through and started to register that have potential negative impact on federally listed species, has only done 5% of these evaluations and consultations. That's it, just 5%. So that all sounds pretty doom and gloom. And I promise you, there is kind of an uplifting part to this. So what can we do to help? Where can we make a difference? And one of the biggest ways is through improving pesticide regulations in the United States by helping to empower the EPA with the right amount of people and funding that they need to do their job correctly, by getting the right people elected into Congress, both at a state and a federal level, and by communicating your desire for better pesticide regulation with your elected officials, and then also by encouraging the Fish and Wildlife Service to help keep our national wildlife refuges as free of toxic pesticides as possible. And I will say that it is a pretty exciting time right now. The EPA announced earlier this year that they fully intend to do consultations on the Endangered Species Act on any new registered active ingredient that comes across as a pesticide. So that's a very big step forward. There are several large pieces of legislation in the United States House of Representatives and the Senate that are dealing with this exactly. And we are currently part of a petition effort. PPAN also was one of the great groups that signed on to help encourage the Fish and Wildlife Service to get agricultural pesticides off of national wildlife refuges. And in the past, we've seen these measures have huge effects. DDT, the chemical that was linked to the decline of the bald eagle, was banned in 1972 because of citizen action. Another really harmful chemical, carbofuran, was banned on use in food crops in 2009. Endosulfan, another really nasty agricultural chemical, was banned internationally in 2011 after a lot of people called in and reported the negative effects it was having on themselves, their children, and wildlife. And then even the partial ban of chlorpyrifos that we saw this year is really, really exciting to show just how powerful it can be when people work together. And then there are some really great pieces of legislation right now. There's the Protect America's Children from Toxic Pesticides Act, PACTPA, which doesn't have the greatest, catchiest name, but it's some really good legislation that was introduced by Senator Cory Booker out of New Jersey, which uses science-based evidence to outlaw several different groups of chemicals, as well as provide better protections for farm workers that are exposed to toxic pesticides. There is HR 4079 in the House of Representatives, the Saving America's Pollinators Act, which was introduced by Representative Earl Blumenauer out of Oregon. And this would not only get rid of some really nasty toxic pesticides that are very harmful to pollinating insects and birds especially, but it would also establish a pollinators protection board where representatives from the chemical industry, beekeeper industry, honey producers industry, private citizens, and environmental groups would all work together to make sure that pesticides are being fully evaluated as they're being introduced. And then also right now, this one's getting a lot of press, the Recovery America's Wildlife Act, or RAWA, has been introduced by Representative Debbie Dingell of Michigan, and this would provide a lot more funding for state wildlife agencies and federal wildlife agencies. And then there's also promoting better practices in our agriculture. One of those is integrated pest management, which is not a new concept. It was first introduced in 1959. And basically what integrated pest management talks about is when you have a pest infestation such as aphids, which are the little guys over here on the left, rather than going straight for the chemicals and immediately drenching everything in pesticide, use the natural processes that are already in place to help take care of that. So when a farmer, rather than going straight for the chemicals, instead tries to promote natural predators such as other insects and birds, when they use scouting techniques where they go out into the field to actually see what pests are out there, when they use natural timing and weather phenomena and really good statistics to drive their decisions on what chemicals that they need to use, most of the time they need to use a lot fewer chemicals. So it saves the farmers a lot of money. It's a great way to make sure that your food stays a lot safer. And this is something that you can talk about with farmers at your local farmers market as well. Are you using integrated pest management practices? What does that look like for you, et cetera, et cetera. And then there's also personal choices that we can all make These are things that you've heard before, I'm sure, but these are still really great points to hit on. Buy organic as much as possible and as much as you can afford. Garden organic at home. So don't use toxic chemicals in your house as much as you can, especially on your home gardens. And if you do, make sure that you avoid synthetic chemical pesticides if you do have to use any kind of pesticides. There's a lot of really great organic products and biopesticides, but if you've tried all of that and you still can't get rid of this particular pest, make sure that you're reading the label. Most of the time on those labels, there are provisions there that you might not have realized. For instance, a lot of chemicals are not designed to be used during the day because of how it can endanger bees that are more actively foraging during the day. Many chemicals are advised not to be used within so many hours of a rainstorm as well because of their water solubility. So just make sure that you're using your chemicals correctly. Plant native plants as often as possible. It's great for your local wildlife. It'll thrive in your local area because they're already designed to be there. And as much as you can, talk to your representatives and let them know how you feel about these issues. And Joyce mentioned it at the beginning, but I'd be remiss not to mention it as well. This fantastic piece of legislation that People and Pollinators Action Network has played a huge part in getting onto the legislative floor in Colorado that would establish the native pollinating insects protection study. This would be a landmark piece of legislation that could pave the way for other states to take better steps towards protecting their native pollinators. So in conclusion, we can and must take flight from pesticides if we're going to protect ourselves and our wildlife. And I thank you all so much for joining us today. And if there's time, I'd be happy to take some of your questions. And with that, I will stop sharing my screen and turn it back over to Joyce.
Thank you so much, Hardy. That was excellent and informative. We really appreciate it. Since Hardy talked a lot about coated seeds, I wanted to mention the failed pollinator human and health bill that I mentioned early on. It did include a proposal to incentivize Colorado farmers to trial non-coated seeds. And there was strong interest in this provision, and we certainly feel like it's worth more exploration, possibly adding a research element to it. And generally, agricultural producers are reluctant to take these kind of risks, thinking that maybe they'll have reduced yields or have pest infestations. But I think, Hardy, you did mention that studies are indicating that there's very little benefit from the coated seeds, particularly in arid climates like Colorado. Yeah. So if we could give a small incentive through some money offered to trial the seeds on some portion of acreage, we think that could be valuable. It would be a small change, but maybe that cultural change where farmers would be sharing the results of their trials. And we imagine that maybe producers that are already working on soil health would be ones that could be early adopters of such a program. So we'd certainly like to explore that in greater depth. And hopefully there's some questions going into the chat box, but before, and we have plenty of time for them, so that's great. Keep them coming. Just want to mention a couple other things before we turn it over to questions. And that's to say that if you did sign up for this webinar, you will be on our email list to receive our monthly e-news. And so that's full of information about more webinars and upcoming events. And just as we've been sitting in this webinar, I received notification from the governor's office that he will be, we asked if they would designate June as pollinator month, and that request was just granted. So I think in our last webinar, we had exciting news too. So you have to come to all of our webinars to hear all the latest, but we will be doing a webinar in celebration of Pollinator Month, and that will be on planting for pollinators, and we'll have an expert panel. So that will be great. And we have a bunch of native and pollinator plant swaps along the Front Range, and we're partnering with a whole bunch of great organizations on those. So I encourage you to watch for those. And of course, as always, so that we can keep bringing these webinars, please consider a donation to PPAN and our partners, American Bird Conservancy and Rocky Mountain Wild. So I lost track of the chat, but let me go back and maybe start pulling out a few questions for Hardy.
And the other thing I'll say real quick too on treated seeds is most of the time the crops that come with their seeds pre-treated, the pests that would actually be killed by those seed treatments are not even active at that time of year. So that's kind of the equivalent of salting your driveway to make sure there's no ice during the height of summer. So it's usually not even temporally matching up.
There you go. Hardy, please discuss using microbial control such as beetle gone, beetle juice for Japanese beetles. I don't know if that's an expertise area of yours, but if you do.
Yeah, so I'm not familiar with either of those two products specifically. However, microbial control is a really exciting field right now. That falls under what are called biopesticides, which they're not a synthetic pesticide and they're not an organic pesticide. They are a biopesticide. They're kind of this weird group in the middle. But what that does is leverage natural processes and natural pest controls to try to work towards invasive pest control. So you might use different strains of bacteria, you might use different microbes that are activated when a certain species ingests them or comes into contact with them, and they can be very effective. One of the best things about any kind of microbial pesticide or bacterial pesticide, not bacterial, no, bacterial, that's what I mean. Yeah, bacterial pesticide is that there tends to be very few environmental negative effects because of that. Whereas with a synthetic chemical, those can live for a very long time in the environment, or they can break down into other very harmful compounds. Whereas when you're talking about microbial pesticides, a lot of times, once they leave their target pest, they don't really have these nasty cascading effects. They will just break down like any other natural compound would. So I don't know those two products specifically, but microbial pesticides are a really exciting area of interest right now.
Yes, and certainly Japanese beetles could be a whole nother webinar. Lisa points out that you should always read labels no matter what product you're using. That's in the chat. And there's a question about the best way to dispose of old seed that has been treated. That would vary state to state. We've seen a big problem in Nebraska. I'll look for something to post in the chat, and if not, I can send that in a follow-up. But I mean, I would consider it hazardous waste, and I would bring it to a hazardous waste pickup. Hardy, would you have a comment on that as well?
No, completely agree. That's what I advise people to do.
I'm hearing a lot about honeybees replacing native bees. Can you speak about this concern? Okay, that's kind of a separate issue. I will say that at the Pollinator Summit in November this year, we will have a panel. There is more and more research about how honeybees can be competitive with native bees. We need to have more plants and more habitat, certainly, to account for that, but we are going to kind of try to tackle that at the Pollinator Summit this year. Senator Jaquez Lewis is here. Thanks for being here, Senator. She'll be introducing one other bill in the next session concerning pollinators and pesticides, and would love support for that. So, and the senator was one of the sponsors of the successful pollinating insect study. So we're very grateful for her leadership in the area of pollinators and pesticides. So thanks for being here and making that comment, Senator. Did you, I see you came on camera, Senator. Did you want to say something? You're welcome to.
Oh, I don't want to interfere at all, but I'm loving the seminar, and my aide is capturing all your slides, and I hope we can use those at the Capitol. I was a little shocked. I'll just comment that I was a little shocked that my colleagues in the Democratic caucus didn't get as excited as I did, at least doing Senate Bill 199. So I cannot stress enough, reach out to your senators and your House reps, tell them how important this issue is. I know they have a lot on their minds. We were carrying all kinds of bills from education, healthcare, COVID response, just lots of things, but this is as important, if not more. This is part of our climate crisis response. So I know how important this issue is across the country, because I see all the pollinator posts and the news items that are heavily responded to. So we've got to get our fellow Colorado legislators excited. So thanks, Joyce, for letting me say that, and appreciate all that you do with PPAN and all the groups. So thank you.
Yes, thanks for your great leadership. Appreciate it.
Thank you very much, Senator.
On a side note, the Boulder plant swap will be happening this Saturday. Cold and rain, it will be happening. So please participate and get your plants dug up maybe today, so you don't have to do it in the cold and snow. But that will be happening. I think there'll be some tents and so on to protect the plants. And oftentimes these are perennials that are hardier, and you'll be able to plant next week, hopefully. Let's see. Are you familiar with Dr. Jonathan Lundgren's work with deer spleen pesticide contamination? Deer
Yes.
mammals are also experiencing jawbone problems and pregnancy and birth issues.
Yes, so Dr. Lundgren's work is some of the more interesting stuff, talking about how large mammals are affected by neonicotinoids, because what we're seeing is wild deer that are having different birth defects, that are having trouble conceiving sometimes, some different bone and spleen issues, as Lori referred to here. And the other way to think about that is deer are large mammals and people are large mammals. We're both large mammals. So it's not going too far to say that there are certainly things that we could see in other mammals that we could start seeing in people as well.
Great, thanks.
And I saw a comment kind of earlier asking if neonics are by themselves or if they can be mixed in with other chemicals. And the answer is both. They are often used as a main active ingredient in a pesticide. They are sometimes used on their own. They are sometimes used in a tank mix setting as well. And one of my favorite neonic misnomers that comes up a lot is that there are three main neonicotinoids used in the US. There's imidacloprid, clothianidin, and thiamethoxam. Thiamethoxam degrades directly into clothianidin. So it's really easy to say that, that the chemical thiamethoxam is a less harmful neonicotinoid because it itself doesn't have as many negative impacts as clothianidin does, but its number one degradant is clothianidin. It's basically just clothianidin in a trench coat and a hat and a pair of funny glasses. So that's what we're talking about when we're talking about thiamethoxam.
We've come to the end of the questions in the chat box. So if there's anybody that would like to speak up, we have 5 minutes left. You'd be welcome to speak up if you have any other comments or questions. And otherwise, we will give everybody 5 minutes to finish lunch. And I want to thank Hardy once again so much for an excellent presentation. We're honored to have you here. And thank you, Chris, also from Rocky Mountain Wild, again, for your very inspirational week of events and presentations. I encourage everyone to go check out. There's still more to this week. I think there's still presentations tomorrow and Saturday, maybe Sunday as well. So please participate in Colorado Endangered Species Week. And thanks again, everybody.
Thank you so much, everyone.